So we're going to be talking about section 2.1, solving solving simple equations. A lot of this is going to be a repetition of what we talked about in section 2.3. But that's good because the more you hear it, the better chance you have of remembering it. In this first section right here, where we've got these two equations, I'm just going to demonstrate to you how when you're manipulating equations, it could be really, really easy, or it can be a little bit more complicated. If we start with this equation, 4x is equal to 16, which I'm sure you know the answer to it already. It's basically what number do you multiply by 4 to get 16. But if we were to solve it in an algebraic manner, of course we start with the equation itself. You know how I like things written down. And to solve for x, you look at what's going on with the x, and the 4 is multiplying it, so you're going to get rid of the 4, you're going to do the opposite of that. And again, the order of operations, which is normally PEMDAS, what we're going to do is just the reverse, which is SADMEP. SADMEP. Okay, so basically what I'm going to do here is divide both sides by 4, and the 4's reduce out on the left, leaving me with x is equal to 4. That's pretty darn easy. But this guy over here, he's going to be a little bit more complicated if I try and solve for s in this case. And oh, by the way, take note of the different variables, the uppercase and the lowercase. If it's uppercase, keep it uppercase. If it's lowercase, keep it lowercase. You don't have the leeway of changing from one to another. There's my little doggy down there. Okay, so I'm going for s, and I'm going to go ahead and put that in red so it's a little bit more obvious to me what I'm doing. And I'm going to manipulate this equation so that I can solve for s. And the first thing that I'm going to do is I'm going to get rid of this w. I don't have any subtraction or addition going on, and the division that I have going on is inside the parentheses, and he's last in line. So I'm going to do the multiplication part first. I'm going to undo that. And the way I undo the multiplication is I use division. And I'm just going to take a shortcut here and just show you I'm dividing this side by w, and I'm dividing this side by w. And these w's reduce out, leaving me with h over w is equal to s over 234 cubed. Okay, so now according to my reverse order of operation rules, these guys are all taken care of. I'm focusing on the exponent, and so I'm got to get rid of him. Got to get rid of that cubic there. And as we've talked about, this is the reverse of cubing something. So to get rid of him, I'm going to take the cube root. And I'm just going to kind of write that again down here rather than in the equation. H over w is equal to the cube root of all of this stuff. So this radical, rips that exponent right off, leaving me with a cube root of h over w, because there's nothing I can do with that. And then inside here, I have s over 234. So I'm almost there. I've almost got to s. The only thing that's in the way is this 234. So I'm going to be multiplying both sides by 234. Multiplying. And I can make this look like a fraction. And these guys reduce down to 1, leaving me with just s. Leaves me with just s, which you know I like on the left side. So s is equal to 234 times the cube root of h over w. Okay, so really, really easy and a little bit more complicated. Okay. So let's take a look at the first problem that we have down here on the bottom. This is pertaining to a car's engine displacement. And what I'm saying here in the lecture notes here is, if just calm down if you're not used to manipulating algebraic equations using a lot of variables. Just follow the step-by-step instructions and you're going to be just fine. Always start with the formula. and then you're going to be substituting in some values if you have them, and you're going to solve in a top-down manner, and you're always going to answer the question with the appropriate units. So let's take a look at this. So we've got, this is example 1. So we have this formula over here that is helpful in finding the engine displacement for a vehicle. And engine displacement, D, is in cubic centimeters, and B is the bore, it's which is the diameter of the cylinder. In the engine, there's a cylinder, just like a can, so to speak, except it doesn't have a bottom or a top. And it's the distance across the cylinder, that's the bore, and it's the height of the cylinder, that's the stroke. And vehicles have multiple cylinders. They could have 4, 6, 8. And then some. I don't know enough about it to speak as much of an authority, but there's a definition of all the parts for that formula. And the question boils down to, for us to find the stroke necessary for a 6-cylinder engine with a 4.8 centimeter bore with 542 cubic centimeters of displacement, and we want to round to 1 decimal. Now there's 2 ways of doing this, and we're going to do it a couple of ways, give you an idea of the 2 different approaches, and then ultimately you're going to decide yourself how you like to solve these. But in either case, the first thing that I'm going to do is I'm going to start by writing down the formula. So I've got D is equal to pi b squared SC all over 4. And now I'm just going to go ahead and substitute in the values. So in place of the displacement, I have 542. 542 is equal to pi times the bore, which is 4.8. And I'm going to put that in parentheses just to make it look clean, times the stroke. Well, I'm looking for the stroke. It says find the stroke. Times the number of cylinders, and the problem says I have a 6-cylinder engine, and this is all over 4. So I've substituted everything in there real pretty, nice and clean. And I'm going for S. Let me put this in red so it's easy to see. Okay, so I'm going for S. Well, I don't know about you, but I'm not a real big fan of fractions, so the first thing I'm going to do is clear out that fraction by multiplying both sides of the equation by 4. That side by 4 and that side by 4. Okay, and what happens over here is it gets reduced out. And over here, I guess I could do that real quickly on my calculator. So I'll pull this over, and I've got 4 times 542. 2168. 2168 is equal to pi times 4.8 squared times S times 6. Okay, so remember now I'm going for S, and all these guys are in the way, and they're all multiplying the S. So in order for me to get rid of them, I'm going to do just the opposite. I'm going to divide by all those guys. I'm going to divide by the pi and the 4.8 squared and the 6. And those are all going to be dropped out, leaving me with just S. But what I do to one side, I have to do to the other. So I get the pi times 4.8 squared times 6 over here. So gone, gone, gone. Of course, really it gets replaced with 1s. And I end up with S, right? Okay, so I'm ready to write my answer. S is equal to, except I'm going to have to figure this out. So let me do that. I already have the 2168 sitting in my calculator, so it's going to be divided by parentheses pi times 4.8 squared times 6. And I'll close the parentheses. And I get 4.9920. What are you doing down there? What are you doing? So this is Pete. He's being a little bit of a pest right now. Okay. So I got this out 4 places. I'm going to go back into the problem and find some directions. It says round to 1 decimal. So it's S is equal to, well, if I round to 1 decimal, I look to the right, and it says I got to bump that up. So if I bump it up, the 9 is going to become a 10. I got to carry the 1. So it's 5.0, and the units for stroke, centimeters. So there's my answer. Okay, so I'm going to do this problem again a little bit differently. So I'm going to start with the formula. There we go. And again, let me put in here what I'm looking for. I'm looking for S. So rather than me substitute the values in right away and then mess around with everything, I'm going to go ahead and mess around with everything and then put the values in. So I'm going to isolate the S. I'm going to start by clearing out the 4, just kind of like I did over here. So I've got 4D is equal to pi b squared times S times C, and that's over 4, and I'm multiplying by 4. Okay, so these guys drop out. So let me clean that up just a little bit because I want this to be very clear. You say, well, Kathy, how come sometimes you got the multiplication sign in there and sometimes you don't? And I don't know. Whatever strikes me. So again, I'm going for S, and these guys are in the way, and these guys are multiplying S. So to break that, I'm going to do the reverse. I'm going to divide. So I've got a pi, a b squared, and a c, and what I do to one side, I do to the other. B squared and a c. And they drop, and they drop, and they drop, leaving me with just S. So S is equal to 4D pi b squared c. So I've changed the formula from D equals all that stuff to just finding the stroke. Now I'm going to plug in the values. S is equal to 4 times, well, what was the displacement? The displacement was 542 over pi times, well, what was the bore? The bore was 4.8. And what were the number of cylinders? 6. S equals, and now the calculator is going to do the rest. So on the top, 4 times 542, let's see what that equals, divided by parentheses pi times 4.8 squared times 6, close the parentheses, and again 4.992, follow the same rounding rules, or the rounding directions that were given to me before, and S is equal to 5.0 centimeters. So you decide. You like plugging in the values and then isolating the variable, or you like isolating the variable and then plugging in the values. So that's example 1.